Hi guys, how are you? I hope you and your family are doing well. Today I'm going to talk about section 12.2, that's vectors. So what's a vector? Well, a vector is actually a quantity that has a magnitude, okay, and a direction. So vector, so it's something that has two things. So first has a magnitude or size or length, so the magnitude, so that would be like the length of the vector, and a direction. Okay, now well, the standard notation for vectors, so usually we write like a letter, let's say vector u, so we write letter u, and above the letter we have like an arrow. Okay, so that's the vector u. Okay, so for example, let's say you have 2 points. So let's say you have point A and here the point B. So if you go from A to B, okay, so you go from A to B. Okay, so then the displacement vector AB. Okay, so you have this vector AB. So we have A, that's the initial point. You start at A, okay, and the terminal point would be B. So we have the vector AB, okay, so that's AB with an arrow above AB, okay, so that's the displacement vector from the point A to the point B, okay, so A, again, A, that's like the initial point. Okay. So you go from A to B, so B, that's the terminal point. Okay, so this displacement vector AB, well, it's a vector because, well, first it has a length or magnitude because, the length in this case would be the distance from A to B, right? So the length, so that would be the distance from A to B. Okay, and the direction would be, the direction of the line which passes through the points A, B, right? So we have this line or the segment going from A to B, so that will be the direction, right? And actually the notation for the magnitude or the length, usually we use, so for the length or magnitude, so of a vector v or vector u, okay, is actually denoted by, so we usually use like 2 bars, okay, 2 parallel bars. Then you have the vector u, and then another 2 bars. Okay, so that's the length or the magnitude of the vector u. Okay. Now, 2 vectors are equal. Again, the vector is characterized by its magnitude or its length and its direction. So 2 vectors are going to be equal if they have, of course, if they have the same magnitude and the same direction. Okay, so 2 vectors u and v are equal or are the same. Okay, so u is equal to v if, well, first, both they have the same magnitude or the same length. So the length of u is equal to the length of v. Okay, and they do have the same direction. So direction of u is same as direction of v. Okay, so for example, here, let's say you have this vector, let's say this is, so here, say this is the vector u, okay, so this is the vector u, okay. Now, if you have, let's say, another vector, let's say this one here, let's say this is the vector, let's say this is the vector v. Well, you see here, u and v, they have the same length, the two vectors. You know, if you measure the distance from the initial point to the terminal point, so both vectors, they have the same length, right? Here, the length of this vector here is the same as the length of this vector, right? And moreover, both they have the same direction, right? They are parallel, so they have actually the same. They go in the same direction, so they have the same direction. So these two vectors actually are equal. Actually, they represent the same vectors. Okay, so they represent the same vector. You can have more vectors like this. So, for example, well, you can have this vector here. This is, let's say, called this vector w. So again, w has the same direction as u and v, and it has the same length, right? So you can also have another vector here, or here, or here, okay, or let's say here, okay. So all these vectors actually, they have the same length and the same direction, so they are equal, so they represent the same vector, they are the same vector. So all these vectors are the same. So all these vectors are the same. Okay, because again, all of them, they have the same length and they have the same direction. Okay. Well, of course, there is a special case of the zero vector. Special case. So the zero vector, that's the vector with length equal to 0. So the zero vector, so it's denoted by like 0, an arrow. It's a vector. Okay, it's a vector with magnitude or length equal to 0. Equal to 0. So actually you can think of the zero vector as just a point, right? A point, you can think of a point as a zero vector because, well, the displacement, or I mean the distance from a point to itself is just 0. Okay, so that'll be a vector 0. Okay, now in the three-dimensional space, well, you can actually, so let's say you have 2 points. Let's say you have this point here, so we are in three-dimensional space. Okay. So yeah, this is x, this is y, let's say this is z, and here's a point A. Let's say this is a point A with coordinates. So the first coordinate, let's say, is 1, 0, and let's say 2. Okay, so we have the first point with coordinates. So x is 1, y is 0, and z is 2. Okay. Now let's say you have another point, the point B. That's the point with coordinates, let's say 3, -1, and then 1, +1. Okay, so if you want to find the vector or this displacement vector from A to B, you know, you go from A to B, so that will be the vector AB. So then algebraically, so you can actually compute the vector AB, and the vector AB, so vector AB, so if you go from, so you go from A to B, right? So then if you want to compute the vector AB, so that will be always, the terminal point minus the initial point. Okay, so in this example, the terminal point is 3, -1, +1, minus the initial point, which is 1, 0, 2. Okay, so then, so what you do, so you subtract the corresponding coordinates. So for example, so here you have 3 minus 1, so that's 3 minus 1, comma, and then you have -1 minus 0, so -1 minus 0, comma, and then 1 minus 2, so we have 1 minus 2, okay, and so that will be the vector, so that's equal to the vector 3 minus 1, that will be 2, minus -1 minus 0, that's -1, 1 minus 2, that's -1. So actually you get the vector, so the vector AB is equal to 2, -1, -1, okay? Let me just here make the following remark about the notation. So you see, guys, for the points, I use parentheses, right? When I denote points, you see here I use parentheses for A, coordinates of the point A, and coordinates of the point B. Okay, so I use parentheses, but for vectors, we use, these angles here. Okay. So that's the difference between notation of a point. So points we use parentheses, and for vectors we use these angles here. Okay. Well, we can also measure we can compute the magnitude of a vector. So we are in 3-dimensional space. So we said, so in this 3-dimensional space, vectors or vector, so in 3-dimensional space, so we have this vector u, and we said we're gonna denote the vector u using these angles here, and the vector, because we are in 3-dimensional space, so the vector has 3 components. So we have u1, u2, and u3. Okay. So then actually the length or the magnitude, the length of the vector u is actually given by the following formula, is actually square root of u1 square plus u2 square plus u3 square. Okay, so that will be the magnitude of the vector u, or the length of the vector u. So for example, let's say we have 2 points A. The point A is the point 1, 0, 1, and B is the point, let's say, -1, 2, -1. Okay, and now so the question is, what's the length of the vector, or the magnitude of the vector AB? Again, vector AB is, so that's the displacement from the point A to the point B, right? So first, what's the vector AB? Well, vector AB, again, guys, B, that will be the terminal point, and A, so here's A, here's B. So you go from A to B. So terminal point is B. So that's -1, 2, -1, minus A. So that's 1, 0, 1. So that will be equal to, so we have -1 minus 1, so -1 minus 1, and then comma, 2 minus 0, so 2 minus 0, and then -1 minus 1, so -1 minus 1, okay? So that will be equal to, well, -1 minus 1, that's -2, 2 minus 0 is 2, -1 minus 1 is again -2, okay? So then the length of the vector AB, so then the length of the vector AB, remember we denote the length by 2 parallel bars, so then the length of AB would be square root of, so we have -2 square plus 2 square plus -2 square. So that's equal to square root of, so -2 square, that's 4, plus another 4, plus -2 square, that's 4. So that's 4 plus 4 plus 4, that's 12, so that's square root of 12. Okay, so final answer, so the length or the magnitude of the vector AB is actually square root of 12. Okay? Now, we can do some operations on vectors. So, for example, we can add vectors. Okay, addition of vectors. So we can add vectors. So how do we add vectors? Well, geometrically, if you have two vectors, let's say you want to do u plus v, okay? So let's say this is the vector u, okay? And here is the vector v. Okay, this is v. So to do u plus v, so what you do is first you start, so you start with u, okay, so you start with u, here's your vector u, okay, this is my vector u, and then at the terminal point of u, so here's my terminal point of u, right? At the terminal point of u, you draw the vector v. So, well, the vector v is this one here, but if you start at the terminal point of u, so this would represent the vector v, right? Because this is this vector here has the same length and the same direction as v, so they are the same vector, okay? So then the vector u plus v would be, so you take the initial point of u, you take the terminal point here of v, and u plus v would be this vector here. So this is actually u plus v. So again, you start at u. Okay, let me do it again. So again, let's say this is vector u. Okay. So what you do, you start with the vector u. Okay. Let me here change the color. So you start at the vector u. Here's my vector u. Okay, and then you add v. So you, at the terminal point of u, you draw the vector v. So here I draw the vector v. Okay, again, this is a vector v because, well, these two vectors, this one here and this one, they have the same, say they have the same length and the same direction. So that this vector here represents also the vector v. Okay, so then the vector u plus v would be the vector which goes from the initial point of u to the terminal point of v. So this is u plus v. Okay. Okay, so you go from initial point of u to the terminal point of V. Okay. Now, algebraically, if you want to add two vectors, so if you have the component or coordinates of the two vectors, so algebraically, so what you do is you just add the corresponding coordinates. So algebraically, okay, algebraically, so what you do, so let's say this is, here's the vector u. Let's say the vector u is given by u1, u2, u3. The vector v is, let's say, v1, v2, v3. Okay, then u plus v is just, so u1 plus v1, u2 plus v2, and u3 plus v3. Okay, so for example, let's say you have, this is vector u. Let's say this is 1, 0, -2. V, it's, let's say, 4, -3, and then 5. Okay, then u plus v would be 1 plus 4, 0 plus -3, then -2 plus 5. So that will be equal to the vector 5, -3, and +3. Okay. Okay, next operation. So after addition, we have a multiplication by a scalar, or scalar multiplication. So basically, scalar multiplication means you can multiply vectors by numbers. So scalar multiplication. Again, it means we can multiply vectors by numbers. Okay, so algebraically, what you do is you just, so let's say, algebraically, so what you do is the following. So let's say you have vector u, it's, let's say, vector 2, -3, 1. So you can multiply, so if you want to multiply vector u by 2, so what you do, so let's say 2 times the vector u, so this is scalar multiplication because you multiply a vector by a number. So it's 2 times the vector 2, -3, 1. So what you do, you just multiply each coordinate by 2. So that would be 2 times 2, then 2 times -3, then 2 times 1. So that will be equal to 4, -6, and 2. So you see, you just multiply each coordinate or each component by the number 2. Okay. So, well, geometrically, if you have a vector, let's say u is a vector, and c is a number. Okay. So then c times u, that's the vector whose length is absolute value of c, okay, because the length is always a positive or 0, a positive number or 0, so that's why we take absolute value. So is the vector whose length is absolute value of c times the length of u, okay, and whose direction So direction here depends whether the C is positive or negative. So if C is positive, then it has the same direction as same as U. Okay, so if C is positive, okay, then it has the same direction as U. And if C is negative, then it has an opposite direction of the opposite of U. And its direction is the opposite direction of U. Of course, if C is 0, then 0 times a vector, it's going to be just the vector 0 mark. So if you multiply by 0, so 0 times, you take a vector, let's say 2, 3, 4. So that's 0 times 2, 0 times 3, 0 times 4. So that would be the vector 0, 0, 0. So that's the vector 0, 0, that's the 0 vector. Okay, so the vector 0 vector is just the vector with 0 coordinates. Okay. Now, if you want to do subtraction, okay, so for example, you want to do U minus V. Okay, so let's say here's your vector U. This is, let's say, U. And here you have the vector V. Okay, this is a vector V. So guys, U minus V, that's actually, geometrically, so if you want to draw the vector U minus V, well, first U minus V, this is like U plus minus V. Okay, so here, minus V, it means that you multiply V by negative 1. So V is multiplied by negative 1. So you multiply V by negative 1. So what's negative minus V? Well, minus V is the vector whose length is absolute value of negative 1 times the length of V. Absolute value of negative 1 is just positive 1. So that's a vector whose length is 1 times the length of vector V. So it has the same length as the vector V. And whose direction, because negative 1 is negative 1 is a negative number, so direction must be the opposite. So this is a vector V. Then minus V would be the vector whose length is the same but of opposite direction. So here, this is actually minus V. Okay, it's the same vector but just of opposite direction. So minus V, that's just negative 1 times V. Now you want to do U plus negative V, right? So here's my vector U plus negative V. Here's negative V. Well, so I have to draw negative V starting from the terminal point of U. So I'm going to start from here, right? And I'm going to draw negative V. So this is negative V. This is, again, it's negative V because, these two vectors here, they have the same length and they have the same direction. So they represent the same vector. It's actually the same vector. So then U plus minus V would be, so you have to go from initial point of U to the terminal point of V. So you go from here to here. So that would be U plus minus V. Okay. So this is U plus minus V. Um, okay, now let me just finish with parallel vectors. Well, two vectors are parallel well if so two vectors u and v are parallel if the vector u is a multiple of the vector v. So two vectors u and v are parallel if u can be written as a number c times v. Okay, so where c is a real number. Okay, so for example are u so are the following two vectors u, let's say 6, -4, and 2. So are u and v. So let's say v is 3, -2, 1. Are these two vectors, are they parallel? Well, yes. It's because u, which is 6, -4, 2, can be written as 2 times 3, -2, 1. So u can be written as 2 times the vector v. Okay, so again, this is here 2 times 3, -2, 1. That's 3, -2, -2, 1. That's the vector v. So yes, they are parallel because u can be written 2 times 2 times the vector v. Of course, here I mean you can here the number is an integer too, but it could be actually a fraction or decimal. It could be any real number. So for example, so this is example 1. Example 2, let's say u is 2, 4, and 1, and v is actually, let's say, half, or not half, let's say it's 8, 16, and 4, right? So then u, which is 2, 4, 1, is actually 1/4 times v, right? Times the 8, 16, and 4. Okay, so u is actually 1/4 times vector v. So yes, u and v are parallel. Okay. Last thing, guys. It's about unit vectors. So actually, a vector, we say that a vector is of unit length if its length is equal, or its magnitude is equal to 1. So a vector is of unit. So vector u is of unit length if the length of u is equal to 1. Okay, so for example, let's say the vector u is equal to 1 over square root of 2, 1 over square root of 2, and 0. Okay, so what will be the length of u? So we said the square root 1 over square root of 2 square plus 1 over square root of 2 square plus 0. So that will be square root of 1 over 2 plus 1 over 2 plus 0. So square root of half plus half, that's 1 plus 0. So that's square root of 1. Square root of 1, of course, 1. So u is of unit length, or it's a unit vector because its magnitude is length, so it is of unit length, or it's a unit vector of unit length. Okay, now there is a last remark. Any vector, you can make any vector of unit length. So for example, let's say you have the vector u, let's say it's 2, 1, 1. Okay, so what's the length of u here? Well, length of u is square root of 2 square plus 1 square plus 1 square, which is actually square root of 6. So it's not 1, right? So this vector is not a unit vector, it's not of unit length, right? So u is not of unit length, right? However, if you want to make it of unit length, so all you have to do, so to make it of unit length, all you have to do is you divide the vector by its length. So if you do u over the length of u. Again, guys, here be careful. So u is a vector. When you divide by the length of u, it's a number. So this is actually a scalar multiplication. It's like you multiply the vector u by 1. So it's like 1 over the length of u times the vector u. Okay? So that's like 1 over the length of u. That's the square root of 6, right? Times u, so that's 2. So that's 2, 1, 1. Okay, so that's 2 over square root of 6, 1 over square root of 6, 1 over square root of 6. Now, I claim that this vector here is of unit length. Okay, because so if you do square root of, well, you have 2 over square root of 6, so that's 2 over square root of 6 square plus 1 over square root of 6 square plus 1 over square root of 6 square. So that will be square root of, so we're going to have 4 over 6 plus 1 over 6 plus 1 over 6. So that will be square root of 6 over 6. So that's square root of 1. So that will be equal to 1. So yes. So you see, I make it of I made the vector u of unit length just by dividing by the length of u. So in general, so u divided by the length of u is of unit length. Okay. Anyway, so guys, I guess I'm gonna stop here, and you can find more details in the lecture notes. See you next time.